Hello, my dear students. Welcome back to Dr. Maran's Chemistry Academy. Right? So we have final questions to discuss here, final exam questions, where consider the following molecules, which is I have 4 different types of molecules here: hydrogen fluoride, boron trichloride, tetrachloromethane, and ammonia. So these 4 molecules have different characteristics and features when it comes to its polarity, when it comes to the types of bond that they have. Now we're going to see which of these molecules are polar. So we need to answer the first question: how to know which is polar and which is not. So we're going to see, so in order to identify the polar, we need to look into the orientation, how the atoms arrange to the central atom. So now when we look into the hydrogen fluoride, we have to understand the bond first. What type of bond? Okay, basically all these have the covalent bond, and we need to study whether this covalent bond is polar or non-polar. So how to look into this? First, what we need to do is we have to check the electronegativity of the atom. So we know that in terms of electronegativity, right, fluorine is the atom that is very highly electronegative compared to the other atoms. So we can see that it is pulling, okay, it is pulling the electron, right, towards the fluorine atom and more closer. So that means, in other words, fluorine will draw the electron more stronger and closer towards the fluorine atom, which means the bond is polar, right? The bond is polar. But then it is not completely, in order to identify whether the molecule, the entire molecule is polar or not, we have to look into the resultant dipole moment. What is the meaning of resultant dipole moment? That means the orientation, how the entire molecules is organized in terms of the side atoms with the central atom. So here we only have one atom, which is hydrogen, and the other one is fluorine. It is very linear. So this is a linear molecule with no cancellation of the dipole moment, meaning to say the bond is polar and the molecule itself is a polar molecule, right? The molecule is polar. So hydrogen fluoride is a polar molecule. Now let's look at boron trichloride. So for boron trichloride, we know that boron is actually a trigonal planar shape, right? It's a trigonal planar shape where we can see it is bonded to 3 chlorine atoms in a trigonal planar, where the bond angle is 120 degree, right? So each bond angle is 120 degree, and what we can see here is the electron is being drawn closer towards chlorine. Okay, I'm sure you all know this because chlorine is more electronegative than boron. So whenever electron is pulled closer towards chlorine, what we're going to see is the bond is polar. The bond is definitely polar. But then, is this molecule polar or not polar? So what we're going to look into this is, we're going to see there will be a equal pulling of electron, which makes the entire dipole moment to cancel out each other. So to cancel out each other, because it's a symmetrical molecule. You can see it's a symmetrical molecule. So any symmetrical molecule, the dipole moment cancel out each other. You have to understand this clearly. Any symmetrical molecule, when there is a presence of polar bond, what we have to understand is the dipole moment is cancel out each other. That makes the entire molecule to be non-polar. So if you ask boron trichloride is a polar molecule, no, it is a non-polar molecule. But the bond is polar, right? Why? Because you have to explain using the symmetrical. The molecule is symmetrical, whereby it cancel out. The dipole moment is cancel out each other, right? Now we look into the tetrachloromethane. Again, it's the same concept as BCl3. Tetrachloromethane, it is bonded with another 4 chlorine atom. And we can also see that this is a tetrahedral or tetrachloromethane, whereby we can see the dipole moment cancel out each other. Why cancel out each other? Because the chlorine draw the electron or attract the electron more closer towards itself as it's electronegative atom, and we can see the dipole moment cancel out each other. Right? Dipole moment cancel out each other. So whenever it cancel out each other, we can see that this is a non-polar molecule, right? And then the last one, which is the ammonia, right? So this is non-polar and this is non-polar. And what about the ammonia molecule? Okay, now we're going to look into ammonia. First, we need to identify the bond, whether it's polar or not. So as I explained earlier, ammonia is a trigonal pyramidal shape, right, with one lone pair of electron, and what we can see, the bond is definitely polar. Why polar? Because what we can see here is the nitrogen is being the most electronegative, not the most, sorry. Nitrogen is being the electronegative atom. What we can see here is it pulls the electron very stronger from hydrogen, and what we can see, the resultant dipole, right? The resultant dipole, or in other words, the mu is not equal to 0, right? The mu is actually the term that we use for the final outcome. What is the dipole moment looks like? So in this case, ammonia, the resultant dipole will not cancel each other. The reason is because the molecule is not symmetrical, alright? And what we can see, because of nitrogen is being electronegative, it pulls the electron from the 3-atom hydrogen more stronger, and the resultant dipole is not cancel out each other. The resultant dipole, where the mu is not equal to 0, hence the ammonia is a polar molecule. Okay, so I hope you can get this, you'll be beneficial from this session, and please follow more closely and subscribe to my channel to get more updates and information. See you soon. Thank you.